Okay, we're given an initial value problem. What in the world is an initial value problem? Well, if you've ever integrated an indefinite integral, you know you get this constant of integration plus c. Well, if you are given an initial condition, you can solve for c, the constant of integration, and that's what we're going to do right now. Okay? This problem, we're going to evaluate it, and I'm looking at it and I'm saying, okay, I look at it, I'm going to integrate it. It's got to be a substitution problem. So let's figure that out. All right? But I'm given the initial condition that when s is when you plug in t equals 1, you get an output of 4. So that's what this function is. We were given ds dt. We're going to solve for the function s. We're then going to substitute what we know into that original function and solve for a constant c. And it's actually going to be quite interesting. All right. These problems can be rather lengthy. This one is not that bad. This one's a little bit on the easier side. But there's actually a whole course dedicated to stuff like this. And the course is called Differential Equations. And I challenge you, go out and look and learn more mathematics. Okay? There's a whole course about this one type of problem. Okay, so let's go ahead and take a look. What we're going to do is we're going to integrate. So let's integrate 12t times 3t squared minus 1 to the third power dt. Let's integrate that. Okay, so let's see what we need to do. Well, we need to first say what u is. So in a previous video, I gave you suggestions about picking u. In this case, again, the higher power of the inside is 3t squared minus 1. So what is du? Du is 6t dt. Well, you may not see a 6t. You see a t definitely, but think about this. 12 is 2 times 6. So you've got your 6 there. It's there. You don't need to do anything special. You just factor out a 2. So let's go ahead and take a look at what that looks like. We've got 2 times 6t times 3t squared minus 1 to the third power dt. All right, we've got that right there. Okay, so now I'm ready to put a ring around what I know, and that is that 6t dt is my du, and the 3t squared minus 1 represents my u. And now I'm ready. I've done the substitution. Let's rewrite the integral. First, I'm going to factor out the 2 across the integral sign. I'm going to say, well, then I have u to the third power du, and I'm ready to integrate this. This becomes 2u to the fourth over 4 plus c. You reduce this a little bit, you get u to the fourth over 2 plus c, and you can factor out that you can factor out that 1/2. I'm going to write it as 1/2 of, in this case, 3t squared minus 1 to the fourth power plus c. Okay, so this right here represents my function s of t. Now, we don't know what c is, but we're going to find that out. And we're going to find that out using the initial condition that s of 1 equals 4. So this is where the fun comes in. We've done the hard part. All right, now we're going to plug in 1 and we're going to set it equal to 4. So that is to say that s of 1 will equal 1/2 of 3 times 1 squared minus 1 to the fourth power plus c equals 4. All right, so now we're going to clean up the inside here. This right here, 3 times 1 squared minus 1, that's just boils down to 3 minus 1, which is 2. So let's go ahead and rewrite this again. 1/2 of 2 now to the fourth power plus c equals 4. All right, now you get 2 to the fourth power, and that's not a big deal. That's just 16. So you're going to have here, again, 1/2 and then of 16 plus c equals 4. Well, half of 16 is 8. 8 plus c equals 4, a very simple equation now to solve, and that is to say then that c equals -4. Okay, So c equals -4. We found our constant of integration. So we can now confidently state our function, our original function, s of t, which equals 1/2 of 3t squared minus 1 to the 4th power minus 4. And so this right here is our original function. Recall that an indefinite integral does not give you the actual function so much as it gives you a family of functions. If you're given initial conditions, then you can find the original function, and that's exactly what happened here in this example. So really a nice example where we have to solve an initial value problem for c. Again, there's a whole course dedicated to stuff like this, differential equations and solving them. But really nice, okay? Really nice. You solve for that constant, you plug it back into the original function, and you've got your answer. So I hope this video was helpful. And as always, remember, like and subscribe.